Good morning, everyone. This is Mlindeni Simo. I'm back again on my YouTube channel. So, guys, to all my subscribers and those who have not yet subscribed to my channel, you may also subscribe to my channel. Then, before we return back to semester 2, I'd like to introduce the geometric optics, whereby we'll be studying about light. Whenever we're studying about light, we have to know that we have the Snell's law, the law of reflection, the critical angle, the index of reflection, and many more. But firstly, before we continue with our study, I'd like to introduce the definition. I want to remind us the definition of the Snell's law. As we all know that the Snell's law, the ratio of the sine of the angle of incidence in one medium to the sine of the angle of reflection in the other medium. Okay, guys, before we continue, we also have the reflection. The refraction. We find the refraction when a ray of light travels through a transparent medium and encounter a boundary leading to another transparent medium. Parts of the energy will be reflected and parts of it will enter the second medium. Therefore, the ray that enters the second medium is bent at the boundary and said to be refracted, which means here we have the two rays. The first ray will enter the first medium, and the second ray will bend. When it bends, it will be refracted. Okay. Secondly, the reflected ray, the incident ray, and refracted ray, they all lie on the same plane. The angle of refraction θ2. It depends on the properties of the two medium and the angle of incident through the refraction. We know that we have this ratio, sin θ2 divided by sin θ1, iyalingana no V2 over V1. Those V are the speed of light in the medium. So V2 means that is the speed of light in the second medium, and V1 is the speed of light in the first medium. These are constant. Have V1 as I stated below, V1 and V2. Okay, this is the diagram which shows us that this is the Snell's law. We have the incident ray, we have the refracted ray, we also have the reflected ray. They are all on the same plane, and this is the representative of the Snell's law. Okay, before we continue, the path of the light ray through refracting surface is reversible. Since it is reversible, it is possible that the light can be originated from A to B. It can also be originated from B to A. This is the vice versa. Okay. Oh, here guys, we have the following diagrams, which shows us the relationship between the speed, the wavelength, and the frequency. Okay. On the first diagram, we can tell that the incident ray, we have the incident ray, we have the refracted ray, whereby they show us that θ1 is greater than θ2, and V2, that is the speed of light in the second ray, is less than the speed of light in the first ray. Why it is like that? The speed of light in the second ray is low because it has a higher index of refractive. When the index of refractive is directly proportional to the speed of light in a vacuum. Therefore, we can how to find the velocity. If we find the velocity, the speed of light in the first or the second medium will be equal to the speed of light in vacuum divided by the index of refraction. And then The other thing that we have to know that V1 will be always greater than V2 if the speed of light in the first medium is on air. Air has the index of refractive which is equal to 1, while the glass have index of refractive which is greater than 1. And then if we divide this, we'll get a lower index of refraction for V2. Okay, as the property said that the speed of light in any material is less than the speed of light in a vacuum. So as we know that anything that is in a vacuum is said to be in air. Light travels at its maximum in the speed of vacuum. The index of refraction. Index of refraction, a medium is defined as the ratio of the speed of light and the speed of light in a medium, which means the index of refraction is the ratio of the speed of light in the vacuum and the speed of light in the medium. As we can see that we have the equation. I stated that this is n equal to c over v. N is for index of refraction, c is the speed of light in a vacuum, and v is speed of light in medium.